Okay, in this video we're talking about a different form, which is standard form. And let me rewrite this as. And it is ax plus by equals c. Notice it's not in y equals mx plus b format. Even though it could be the same equation, it's written in a different format, in a different form. Now you can take the standard form and convert it to y equals mx plus b form or slope-intercept form and then graph it, or you can graph it the way I'm going to show you, which is using the intercepts. So let's just look at an example first. Like 2x plus 3y equals 12. You know, that would be an example of standard form. Let's review slope-intercept form. Slope-intercept form would be y equals mx plus b, and an example of it could be y equals 1/4 x minus 5. And you could graph it using that, which is we already know because we just learned that. In order to graph from standard form without changing it, what you have to do is you have to look at the x individually and you have to look at the y individually. So I'm going to rewrite this and I'll show you what I'm talking about. Okay, so we're going to break this down into two separate equations. The first equation, we're going to pretend like 3y isn't there. So it's going to be 2x equals 12. Notice I just forgot about the y altogether. The next equation, we're going to forget about the x altogether. So I really just have 3y equals 12. Now that I've got two different new equations, I'm going to solve them. So 2x equals 12. Well, x is being multiplied by 2, so we're going to divide by 2 on both sides. And we get that x equals 6. On the right-hand side, we got 3y equals 12. Well, y is being multiplied by 3, so we're going to divide by 3 on both sides. And we've solved now for x, and we've solved for y. What we're going to do now is we're going to write these as coordinate points. What you should notice is that x equals 6 here. And the coordinate points is x first and then y. So x equals 6. So 6 would go where x is. But there's nothing for y here because we made it 0. So this coordinate point would be 6, 0. Over here, y equals 4. And we had eliminated the x in order for this to happen. So in this case, x would be 0. So the x-intercept is at 6 and the y-intercept is at 4. And these are the 2 points that show that. So if we were going to graph this equation, I'm going to draw a very rough coordinate plane, my y-axis, my x-axis, and x was 6, so 1, 2, 3, 4, 5, 6, and I put a dot here, and y was 4, so I'm going to go up 1, 2, 3, 4, and my point goes here, and then I just connect those dots as best I can, and there's my line. And I've graphed it. Notice I didn't have to change it into, I didn't have to find a slope, I didn't have to find the slope-intercept form. I can just use the equation as it's written, because all I need is 2 points. So here's point 1 and here's point 2. So let's look at some of the problems here. We'll do a handful together and then you can work on some by yourself. Let's just pick, let's do C, and then we'll do I, and let's do J. Okay, so we'll do C, I, and J. And then the rest of them you can do by yourself. Alright, so we'll start with C. So I'm going to write it again. Okay, so I'm going to write this as 2 separate equations. I'm going to do negative 5x equals 15 and 3y equals 15. Notice that in one case I made this go away, and in another case I made this go away. And you're going to do that every time. So I'm going to divide by negative 5 on both sides here, and I get that x is negative 3. On this side I divide by positive 3, and I get that y is 5. So these are my 2 intercepts. X is, I'm going to write them as coordinate points. Here, x is negative 3, which leaves y for 0. And over here, y is 5, which leaves x at 0. So these are my 2 points. I'm going to look for those answers on the sheet. And I see it right here, and it says who. So there was the answer for C. Let's try I. Alright, so we're going to have 2 equations, negative x equals 6 and negative 4y equals 6. Again, I took this one away to get the first equation, and then I took this one away to get the second equation. And if you think about it, this is negative 1x, so let's change that. And so I'm going to divide by negative 1 on both sides, and I get that x equals negative 6. Over here, I'm going to divide by negative 4 on both sides, and this will reduce to negative 3 over 2. Or negative 1.5, or negative 1.5. It depends on how they've written it in the answer sheet. But again, if I'm writing my 2 coordinate points, x is negative 6 here, and then 0, y would be 0. And then over here, y is negative 3/2, which would leave x at 0. So these are my 2 answers that I'm now going to go look for. And I see it here, because. Alright, so we're going to try J now. Notice that this one isn't what we want it to be yet. We do have to make a change here. If you remember, the formula is ax plus by equals c. So this is c, and it needs moved over here. So that's the very first thing that we need to do. So we're going to add 12 to both sides of the equation, and it's going to go away from here. So we're going to have 4x minus 3y equals 12. Alright, so we're going to create our 2 equations, and then we're going to solve those 2 equations. Again, every time we do this, what we're really trying to find is the x-intercept and the y-intercept. To find the x-intercept, you make y 0. To find the x-intercept, you make x. To find y-intercept, you make x 0. It's very hard to say, but it's not hard to do. So 4x equals 12, and negative 3y equals 12. So there's our two equations. We're going to divide by 4, and we get that x equals 3. Over here, we're going to divide by negative 3, and we get that y equals negative 4. Writing our 2 points, in this example, x is 3, so it goes first. And in this one, y is negative 4, it goes second. These are our 2 points that we're going to look for. This is the x-intercept, and this is the y-intercept. And I see it here, it says it. So there are, 8 more problems for you to do to get practice. I want you to do them and show me when you're done. If you have any questions throughout, raise your hand and I'll answer your questions.